And we are live.
Hello again, everybody. Welcome to our second keynote speaker. It is my honor to introduce to you Romaric Redon. He is the head of the artificial intelligence branch at Airbus Defense and Space, based in Toulouse, France. Romaric has worked at Airbus for 20 years, and he's the principal advisor on artificial intelligence technologies. He is a senior expert on AI and leads the development of AI and computing technology road mapping activities for Airbus. He also contributes to the implementation of various symbolic and data-driven AI technologies for a wide spectrum of applications at Airbus. He collaborates with internal and external stakeholders to foster and maximize the adoption of AI in the aerospace and defense sector, with the objective to achieve a convergence of AI technologies, aerospace market requirements, and customer needs. Romaric is called upon regularly to speak about Airbus's AI activities, and we're very fortunate to have him with us today to discuss Airbus's AI capabilities, the challenges of incorporating AI into aerospace systems, and the shaping of AI collaboration. Please join me in welcoming Romaric Redon as our keynote speaker.
Thank you very much, Harry. Do you hear me properly?
I can indeed.
Okay, thank you for the opportunity to speak today. And good morning, good afternoon, good evening, bonsoir also. For me, it's more the evening time since I'm based in Toulouse. And I'm very happy to go through some of what we do with artificial intelligence inside Airbus. So indeed, I am the head advisor for artificial intelligence for Airbus. And for sure, you know Airbus for the space activity because you are space colleagues. But my position is really to look across the different divisions of Airbus. So to look at what we can do for commercial aircraft, for helicopter, for military aircraft, for satellites, also for unmanned aerial vehicle. And so let me start to give you with an introduction about what do we mean by artificial intelligence in Airbus. We can spend a lot of time to discuss what is artificial intelligence. Here, I'm really focusing on what we enable with artificial intelligence. What are the applications we can have? On first, we can assist perception task. And when it is linked to making sense out of images, this is computer vision. When it's making sense out of sensor data, this is more time series analysis. Sorry, there were some technical issues, so we will resume from these slides where I was somehow making the parallel between what we do for space and what we do for aviation. Everything starts with collecting a lot of data from fleets of aircraft or a fleet of satellite. So to collect space imagery data from satellites that we operate, we have the One Atlas platform. To collect aviation data coming from aircraft which are operated by airlines, we have the Skywise platform. On both of these platforms are based on big data on the cloud technology. And they are a key enabler to do artificial intelligence, which I will show in the other, in the different use case that will come. So I still see that there might be issues with the video. I hope everything is fine.
Everything looks fine on our end.
Okay, so let's start with some examples. So I spoke about different application classes. The first one was pattern recognition on time series analysis. And this is used for years in the space industry to do anomaly detection. So I put example there about the kind of anomaly that we want to detect on the link to a publication. The next challenge is really also how we can bring these anomaly detection capabilities based on artificial intelligence on board to improve failure detection, isolation, and recovery. And these are some of the activities we are currently looking at inside Airbus. And if I want to make the link with what we do on commercial aircraft, for sure, predictive maintenance is a very common topic for using AI, and we've been using it for sure to do also anomaly detection, but also to do traffic prediction, especially linked to the COVID crisis. So the way to really see how the traffic will go up again, depending on the limitation on the different states for travel. So these are stuff which we do and where we use a lot of machine learning to build models based on data, either for anomaly detection or for trend monitoring. To give you an example on computer vision, for sure, there is a lot in the space imagery domain, and I will do a specific zoom into that later on in my presentation. So this is an area which I think in all what we do inside Airbus, this is maybe the area where we are the more advanced internally in terms of applying artificial intelligence. And I will describe that in more detail later on. To make the parallel also with aircraft, I mean, we do use also computer vision for aircraft. It's more new for aircraft. Especially we are using computer vision to do vision-based navigation. And we did last year a specific world premiere where we were able to demonstrate on an A350 that we were able to do autonomously the taxiing, the takeoff, on the landing based on cameras. And this was quite a very good start, let's say, which was even acknowledged by people like Yann Lequin, I mean, as famous as Yann Lequin.
Okay, we're good.
Yeah, okay. So this was another example of what we do on natural language understanding and processing with a virtual assistant, which we have built to go inside the International Space Station to support astronauts. So we had already two versions of this virtual assistant, which is this flying robot, spherical robot that you see here with Alexander Gernst on its first mission. So also making once again the parallel to what we do in commercial aircraft, we are using natural language understanding and processing to do air traffic control speech recognition, which is actually quite a challenging case, because you have to deal with a lot of noise, accent, multilingualism, potentially high speech rate inside the cockpit. And there is an example here of what you can get with just off-the-shelf speech to text and custom speech to text that we can build. So really, when you try to understand the phraseology of ATC, you need to build custom speech to text capacity so that you get the right sense out of speech. And this is something where on which we work. I will give now some example linked to decision making. So for sure, for planning acquisition of our satellite, this is a complex optimization problem where we have to maximize really some requests, and we have to deal with weather uncertainties. And so to build up the plan on the more efficient plan, taking into account weather uncertainty, we are using AI to do that. And especially we even open source some of the library we have built for this purpose. I mean, what we have open source is the generic part, but we are using it to solve this problem. And same thing, making the parallel with Airbus commercial aircraft. We are using the same capacity to do optimization of trajectory, taking into account weather uncertainty, which is actually is an important topic for the commercial aviation, because through optimizing the trajectory, we can really save a lot of CO2. And this is one way to really improve our sustainability. And so a big topic for us, for sure. In all what we do, there is a common aspect, which is we have to ensure trustworthy and safe artificial intelligence. On the commercial aviation, we are working on new standards to enable this to move to data-driven approach. Also, we do the same at the moment, linked to European Space Agency and the standard body of European Space Agency. Also trying to define new standards for the way we would qualify machine learning application for space. The challenge is always to ensure the validity, the robustness, the fairness, the explicability, and to deal with the security of our systems that would integrate some artificial intelligence. Also, I would like to mention that a lot of that is coming fresh from research in terms of what are the applicable methods we can use as means of compliance, for example. And we do have collaborations with Canada through the DEAL project, and with several universities in Canada, really working on the topic of robustness of neural network, for example, formal verification of neural network, and this kind of. This is an open topic of collaboration with Canada. We're really working on this aspect of trustworthy and safe artificial intelligence. Now, I would like to zoom. I mean, there was no way I could cover all the topic in depth of what we do with artificial intelligence, but at least I was eager to provide some zoom on what we do for space imagery. So first aspect is, I mean, we have to be aware that already today we have more than all of the emerged lands on Earth, which is covered daily by Earth observation satellite. So we start to have really very fresh information about Earth. Also, not a small amount of this image are really used today. And we really want to make all this data available to build a lot of services. Some of these services, we are building them by ourselves, but also a lot of that is built by external partners where we collaborate with them, and they are using some of the data which we produce. So today, just to give a reminder about the kind of resolutions which we have on the optical domain. So we have capacities which are from the 22-meter resolution to the very new Pléiade Neo capacity, which is 30 centimeter resolution. On here you can see the difference on Nice airport in France of what you can get with this different level of resolution. And for sure, what we can do now with 30 centimeter resolution is opening really new area in terms of services which we can offer. So we have the One Atlas digital platform. Also, we have a specific platform which is SoBlue, which is hosted on sovereign cloud in Europe. And we have the UP42 platform, which aims at combining spatial imagery with also other source of data, of geospatial data, mostly terrestrial sources of information. And now I will give you some insight. So first, there has been a breakthrough. I mean, we don't sell any more images because people don't want images, they want information. And the artificial intelligence is in fact a very key enabler because it provides scalable capability to detect and classify objects, to classify land cover, to detect change. And I've underlined the scalability because the performance is somehow to the same level than the human. Sometimes it's better, sometimes it's less good as the human. But really, in terms of scaling, it outperformed the human. So we can really scale to large region, and we can also get that done on a regular basis. And I will give you some examples. So detect and classify objects. So for sure, we can detect aircraft. We can detect other objects such as cars on car park. We can detect boats. And what do we do with this detection of objects? So here are some examples. So this is an example to follow cars on car park to assess the impact of the COVID on a car manufacturer. In fact, the cars we monitor are not the cars which are produced, but the car from the people who are coming to work in the company, in the factory. So in fact, we can deduce the level of the activity of the plant depending on the number of the cars. And we can do that on a regular basis, so we can observe and count the number of cars over time. And this is the kind of stuff which we get. So we don't care anymore about the image. I mean, we have the analytics information about the number of cars. And here in green, these are which are weak value. The green dots are the weak value. The red dots are the weekend value. And here you can start issues. You start to see really the COVID period where you had a lot of very low numbers while weak period during the week, which is really the COVID effect. Also, what we can do by counting on finding boats, for sure, we can also map and fuse information with what we have from AIS, which is what the boats are providing as information for their position. And we can spot really discrepancy between what we see and what is transmitted. And this has a number of good applications for finding illegal fishing activities, fighting drugs, or other aspects. Now going to another aspect, so we are no more detecting object, we are detecting change, which is quite challenging. So here we can highlight change, for example, to update the cartography, new buildings which have been spotted. Also, another example here is for monitoring the road construction. So you can see also highlighted the change which have been detected. This is also very useful for another use cases, which is linked to land classification and for environmental purpose. We are monitoring how oil palm is contributing to deforestation, and we are capable to do identification of oil palm and ensuring that oil palms are not contributing to deforestation using space data. Another aspect is linked to land cover is this challenge of extracting these field boundaries. So this is also something we can do with AI, and it serves a lot of purpose because you can compute for sure surface and many other aspects having the boundaries. Sorry. Also, another example of change monitoring, which is linked to looking at whether we have more or less containers in harbor areas. So we are able to spot areas where we have less or more containers. And this is for sure also quite important to monitor the stocks and to somehow make some economic analysis and to deliver some insight. So these were some examples, but generally speaking, we are covering a wide domain, a wide numerous market, from defense to agriculture to civil institution, to avionics, to maritime surveillance, to forestry, and we are doing much more into really environment more generally with pollution detection, also methane detection, methane leak detection now, oil, gas mining, and location-based services. So these are all different markets which we can derive services for using artificial intelligence. And also we do some of that inside Airbus, but also we work with a lot of external partners. Some of them are there, who are somehow providing algorithm, and we have built a platform which is the intelligence playground, where they can run their algorithm at scale on our large qualification database, which we have acquired for years, so that we have somehow the capability to qualify the performance of the algorithm, and this performance level are also associated to some diamond scale, silver, gold, platinum, and this is then going into some of our services. So this is something where we really offer third party to build more stuff based on space data. And yeah, this is the end of the Zoom on space imagery. The key takeaway from my presentation is that for sure, the first step is to store and collect the data, and this is what we do building this digital platform. And then we can scale AI to boost our competitiveness, but also the competitiveness of third party that are working with us to deliver more useful insight from space imagery, for example. Also, as we plan to use AI more inside our flying platform, we do care about building safe and trustworthy artificial intelligence. And this is an area where we are doing a lot of research, including with Canadian partners. And I thank you very much for your attention, and I'm happy to answer questions.
Thank you, Romaric. This is Jeff Longodoc back with you again to handle whatever chat questions may be incoming. That was a very rich presentation, I would say, and there was a great deal of information presented there. As we wait for chat to begin to roll in, I had a couple of questions that maybe I can take advantage of the fact that I'm already on screen here to ask. One of the things you mentioned, or one of the applications you mentioned of AI fairly early on, is its use in predictive maintenance on the air side of things. I guess the same would be true for space as well, but I'm wondering to what extent, or if it's been measured, the use of artificial intelligence techniques and practices improve, how the use of that AI capability improves on the result of predictive maintenance, especially on the aero side.
I mean, on the aero side, the main gain which we have from AI is the improvement of the operational availability of the aircraft. Because we can spot defect before they have actually an impact on the operation. I mean, aircraft have fail-safe architecture, so you can fly with an issue on board for sure, because you have a fail-safe architecture each time. But you have an operational impact because you will need to fix the issue on your next leg. So this is the major impact we have on commercial aviation. On space, it's quite different because, of course, we don't gain the same kind of credits, but it's really a matter of lifetime extension, especially on the satellite, to have a much better understanding of the degradation and potentially to optimize the way the satellite is operated so that we can gain even more lifetime extensions from the satellite, on the satellite.
And does the artificial intelligence analysis significantly improve over the collection and analysis of data, let's say you might say manually or something like that? You know, on the air side of things, with which I'm a little bit familiar, predictive maintenance has been practiced for a long time. Of course, it's been refined and it's gotten better over the years. So I'm wondering if the application of algorithms and other sorts of higher level analysis improves the predictive ability with respect to the operation, let's say, of an aircraft fleet, such that you may take an airplane out of service even before the regular predictive maintenance practices would have indicated it should come out of service.
Yeah, indeed. We are now capable to spot a defect that would be first of a kind. Generally in the history of predictive maintenance, the topic was first to learn trends that would occur on a fleet of aircraft, and to be able to know that this trend exists, and you can somehow learn from these trends for other for other challenge that could come. But now, with the topic of anomaly detection, it's more to find out the first event and to detect the first anomaly. The challenge there is always that anomaly detections is spotting something which is different from the normal behavior, and you still need to be accurate on qualifying the normal behavior, because you can have a lot of changes which are not linked to something which is malfunctioning that could create some change. So this is the tricky part of anomaly detection, but this is really where we are working at the moment more on this aspect. Trend monitoring is really well managed. This aspect of anomaly detection is still something which is already used, but also to be improved.
A question from Harry Cole, actually. From a decision-making perspective, what are some of the policy changes that govern whether or not AI is allowed to make certain decisions?
In terms of the decision making, it's very much linked to to the criticality of the system. If it's mission critical, or if it's not critical. We are speaking about some of the stuff in predictive maintenance. Some of this stuff are business critical, which means there is no impact on the mission, there is no impact on the safety of whatever of anyone, but still, if it goes wrong, it could have business impact, and if the lifetime of the satellite is not the one which we have sold, there will be penalty and so on. So this is really the domain of business critical. Then we have mission critical. Mission critical is if we have an issue with what the AI is providing, we may have an issue with the mission. And then you have the safety critical aspect, which is also a topic for space, because we are using some space for the positioning system, for the positioning systems that are used with satellite, especially the one which are used by commercial aviation. There could be safety impact for issue with this positioning system, and it's even more the case for commercial aviation. So for sure, the level of sophistication of the architecture is different to take into account this aspect of the criticality. And also in terms of standards which are applied, I mean the kind of guarantees which you have to demonstrate is different depending on the level of the criticality. But this is still a very open topic at the moment, because we are making evolutions on these new standards, either for space or for commercial aviation, because they were not written, I mean, they were made at a time where machine learning was not existing. So now we have to adapt them to deal with data-driven approach. And this is what we are currently doing. We would like to have formal proof for a lot of what we do. This is what we usually like a lot, when we can provide formal guarantees. Unfortunately, this is not something we can do for all type of artificial intelligence, but we can do that for some of it, and for some other part we have to manage with statistical guarantees. And this is a topic on which we are working at the moment to find out exactly what kind of guarantees we can provide. It's, by the way, the kind of topic we manage in collaboration with Canadian universities in the DEAL project when it comes to deep learning.
Actually, that refers to another question regarding validation. You know, in the old days, where it was actually photographs that were mainly what was being harvested and sold to customers, the issue of ground validation could be very tricky. I remember working with a fellow who was involved in fixed wing information gathering as well as satellite information, and to validate the information at the ground, on the ground, often involved going into a farmer's field or something like that and trying to say, well, is this corn got enough fertilizer or doesn't it? At which point sometimes he would get chased out of the field by the farmer who didn't know what he was doing. You know, the problem being to validate the information. And I wonder if this is an issue that AI finds significant to deal with. You mentioned the confidence level that customers or that users of AI may have in the products of that process. To what extent is this an issue in terms of what Airbus would like to develop as a product from AI?
No, it is an issue. It's something we need to manage, and this is why we have this process to qualify our AI. And to qualify properly the AI, we need enough ground truth information, and sometimes this ground truth information is not always available. And as a result, we have to be careful on the kind of service that we build. Coming back to the example of the topic of counting vehicle, if the topic is somehow to count the number of vehicles on a car park, if you do an error on some of these vehicles, it's not an issue, especially if you also look at the tendency over time of whether you have more or less vehicle. So for example, for this kind of application, the impact of missing a car is not a big one. For other applications, really the level of expectation is really indeed very high, and sometimes we don't have enough ground truth or labeled data to really come to the level of performance which we have. Also, I want to mention that we are working on change detection. And change detection is something very subjective. So here, change might be relevant for some customers and might be not relevant for some others. So we are also working with tools to do active learning now, which means having some ways to acquire more ground truth on the way we train our algorithm, so that we improve the confidence on the performance of our algorithm. But still, yes, having gold standards ground truth is the challenge for space imagery, because we can get a lot of imagery that we can get a lot of data from imagery, but we need to have this ground truth. So we need to look into open data and to try to get the best of what other data we can have to build this ground truth. And still, sometimes we do have people which have to look and see, to collect some ground truth, indeed.
Romaric, I'm afraid we're going to have to wrap things up now. Your presentation has probably generated more questions than we've nearly had a chance to answer. I think we can all stay tuned to Airbus, visit the website from time to time, and find out more about what Airbus is doing in the field of artificial intelligence. I'd like to thank you today for your time and for your information, and to thank Airbus as a sponsor of the CASI Astro 2021 conference. It's been very valuable and a great facilitator. Thank you very much for your presentation today.
Yes, thank you very much. And yeah, looking forward to do more stuff with Canada for sure on artificial intelligence, on for space. I mean, I've seen. I mean, the AI ecosystem in Canada is also very interesting for us, and we look forward to do much more, putting together AI on space in Canada. So thank you very much for hosting me, and looking forward for any opportunity to collaborate. Thank you.
Oui, espérons que ça sera à la prochaine au lieu de adieu.
Oui, oui, c'est ça. Merci beaucoup.
Thank you once again. Thank you once again. Bye-bye.